Hi, my dear students in grade 6. Now we are going to make our mathematics lessons discussion. During semester 1, what we have seen in all our lessons or the topics covered in the lessons during the semester 1 exam. So please pay attention. These rules are very important and will help you to solve the mathematics semester 1 exam review sheet. Let's start. So during semester 1, the topics covered in mathematics were: we have seen the GCD and LCM. We have learned how can we find the GCD and LCM of two natural numbers, the steps to do so. The second lesson was about lines, the positions of lines, perpendicular lines, parallel lines, and intersecting lines, and the most important properties of parallel lines and perpendicular lines. In our third lesson, we have studied powers of exponents 2 and 3. We have seen the definition of powers, how can we write a multiplication sentence as in power form or a power form as a multiplication sentence, and we have calculated powers of different exponents. We have seen powers of 10 and 1 over 10 and the usage of powers of 10 and 1 over 10. What do we mean by powers of 10? And in our lesson, which is the order of operations, we have studied the order of operation and the most important rule, which is, as you can remember, the PEMDAS. The PEMDAS, which is P shows that the parenthesis is the strongest, then E, which is the exponents, M, multiply or divide from left. These multiplication and division are of the same power, so we start them from left. Finally, we have the addition and the subtraction, also we do them from left. Now we are going to see the most important rules of each lesson aside. In this lesson, we have seen what are prime numbers. Prime numbers are all the natural numbers that have exactly two divisors. Any prime number can only be divided by 1 and itself only. Examples of prime numbers are: 1 is not a prime number, 2 is a prime number, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, etc. If we take the number which is 7, the only divisors of 7 are: 7 is divided by 1, it gives me 7. 7, it cannot be divided by 2, cannot be divided by 3, nor by 4, nor by 5. 7 cannot be divided by 6. 7 can be divided by 7, it gives us 1. So the divisors of 7 are 1 and 7. Because of this, we call 7 as a prime number, and all the other numbers are the same. But every natural number can be decomposed into prime numbers. This method is called the prime factorization. So we have other numbers that are called the composite numbers. We can decompose them into prime numbers using prime factorization. How can we make prime factorization? To decompose a natural number into prime factors using prime factorization, we try to divide this number starting from 2. If we can divide the number by 2, then we get the answer. If we can't divide the number by 2, so we try to divide the number by 3, and so on. If we can't divide it by 3, we try to divide it by 5. We don't try to divide the number by 4 because 4 is not a prime number. We can do so applying criteria of divisibility. We have seen criteria of divisibility. When can we divide a number by 2, by 3, by 4, by 5? A number, how can we know if it's divisible by 6, by 9, and by 10? These criteria of divisibilities are found on your copybooks. So refer to these criteria of divisibility because they will help you very much. When does the prime factorization finish? This prime factorization finishes or stops when the answer of division is 1. Let's try a number. Let's decompose the number which is 12 into prime factors. So we write 12 and we do a vertical line. Can we divide the 12 by 2? Yes. Why? Because the ones is even. So we divide 12 by 2, so we write 2. We can get the answer. 12 divided by 2 is 6. Can we divide 6 by 2? Yes, because the ones is even. So we divide 6 by 2. The answer is 3. Can we divide 3 by 2? No. So we divide 3. Only it can be divided by 3. The answer is 1. So when the answer of division is 1, the prime factorization stops. What are the prime factors of 12? These are the prime factors of 12. So we can write 12 equal as product of prime factors 2 times 2 times 3. So these are the prime factors of 12. Now, after we finish the prime factorization, we should choose the LCM and the GCD from the prime factorization. What do we mean by LCM? Least common multiple. GCD is the greatest common divisor. So to find the LCM and the GCD of any two natural numbers using prime factorization method, to find the LCM, we choose the more common and not common prime factors. To find the GCD, we choose the less common prime factors only. Let's find the prime factors of the number, for example, 20. Can we divide the 20 by 2? Yes, because the ones is even, so by 2 it's 10. Can we divide 10 by 2? Yes, because the ones is even. By 2 it's 5. Can we divide 5 by 2? No. We can divide 5 only by 5. The answer is 1. So the prime factors of 20 are 20 equals 2 times 2 times 5. These are the prime factors of 20. Now let's try to find the LCM of 12 and the 20. To find the LCM, we choose the more common prime factors first. Here as common factors we have 2. Here we have 2 times, and here we have 2 times. So we take 2 times. We don't have any more common factors. Now we look for the not common prime factors. 3 is found in the prime factors of 12, but it's not in the prime factors of 20, so it's a not common prime factor. We take it. 5, it's found in the prime factors of 20, but not in 12, so it's not common. We take it. Now 2 times 5 is 10, times 6 it's 60, so we find the LCM. Now let's find the GCD of 12 and the 20. In GCD, we only choose the less common prime factors. 2 times and 2 times, so we take 2 times. 3 is not common, we don't take it. 5 is not common, we don't take it, so 2 times 2 is 4. In this way, we find the LCM and the GCD using the method of prime factorization. In our lesson, which is lines, we've studied the positions of lines. Any two straight lines with respect to each others they might be parallel. They might be parallel horizontally, they might be parallel vertically, or they might be parallel oblique. These are the positions of parallel lines if the lines do not meet or do not intersect. Intersecting or concurrent lines, if they meet in a point, this is a line and this is a line, they intersect in this point, so we call these intersecting or concurrent lines. Confounded lines, if lines have all points in common. This is the first line and this is the second line. These two lines, the blue line and the red line, we call them confounded lines. Perpendicular lines, if they intersect, so if two lines intersect, if they intersect in a point and form a right angle in between equals to 90 degrees. This is the first line. And this is the second line. They intersect together, and in between these two lines they form a right angle, so these are perpendicular lines. To draw two perpendicular lines, we always use the ruler, which is the set square. So use the set square to draw two perpendicular lines. Now, the distance from a point to a line is the perpendicular line drawn from the point to the line using the set square. Properties of perpendicular lines and parallel lines. If we have any line, this is the first property. To draw a perpendicular from a point to a line, if we have a point away from the line and I want to draw, how many perpendiculars can we draw from the point to the line? From the point to any line, we can draw one and only one perpendicular. Now, if we have any straight line without assigning any point, how many perpendiculars can we draw to this straight line? We can draw many perpendiculars to this straight line. We can draw infinite number of perpendiculars to this straight line without assigning a point. The third property, from a point to a line, we can draw one and only one parallel. If we have this straight line, how many parallels can we draw? We can draw infinite number of parallels from above and from below, so infinite number of parallels. The fourth property, to a line we can draw many parallels, and here if we have a straight line and a point, how many parallels can we draw passing through this point? We can draw one and only one parallel to this straight line. So these are the properties that we will use in our lesson, which is the positions of lines. In this important lesson, which is about powers, we have defined powers. What is a power? A power is to represent repetition of multiplication. A repeated multiplication sentence is written in power form. For example, if we have 2 times 2 times 2, this we call a repeated multiplication sentence because we are multiplying 2 by itself many times. How we can write it as a power form? What is the number repeated? The number repeated is 2. How many times are we multiplying 2 by itself? 3 times, so we write it to the power 3. So this how we change from a multiplication sentence form to a power form. Now, what is the power form? The power form is a to the power n, where a represents the base and n represents the exponent. So when we have a power form, which is a to the power n, we write it as multiplication sentence, a times a times a times a. How many times? As the exponent, which is n. So we multiply a by itself n times. We have something very important in powers. We call it powers of 10. Why do we call these powers powers of 10? Because they have base 10. How can we denote powers of 10? It's written 10 to the power n as in power form. It's no need here to write 10 to the power n as a multiplication sentence. We directly write the answer. From the base 10, we take the 1, so 1 we take it from the base 10, and we add zeros as the exponent, which is n, so we add n zeros. We have very important rules in powers, which are any number to the power 0 gives us 1, so a to the power 0 equals 1. For example, if we have 3 to the power 0, it's equal to 1. If we have 17 to the power 0, it's equal to 1. If we have 2348 to the power 0, it's also equals to 1. The second rule, which is a to the power 1 is equal to a. Any number to the power 1 gives me the number itself. For example, if we have 77 to the power 1 gives us 77. In our lesson, which is powers, we also have to apply order of operations if we have a numerical expression. In this numerical expression, we have parentheses, we have exponents, multiplication or division, addition or subtraction. Then what will be the order of operations? The order of operation will be parentheses is the strongest, so we start with the parentheses. If we have more than one parenthesis, we start each parenthesis from left. After we get rid of the parentheses, we see if we have exponents. When we finish the exponents, we should multiply or divide from left. Then At the end, we add or subtract also from left. Very important rules in powers. If we have a whole natural number and we are multiplying this whole natural number by powers of 10, what do? The number stays as it is and we add zeros to the right as the power. For example, if we have 295 times 10 to the power 4. 295 is a whole natural number. Because we are multiplying it by a power of 10, so the number 295 stays as it is, and we add to the right zeros as the exponent, which means 4 zeros. The second rule, to multiply a decimal number by powers of 10, we move the point to the right as the power. For example, if we have 5.62 times 10 to the power 2, here we have a decimal number, we have a point, so we should move the point to the right as the exponent. So we should move it to the right 2 digits. We move it 1, 2, the point will fly, and the answer is 3562. Now the third rule, to multiply a number by powers of 1 over 10, we move the point to the left as the exponent or as the power. For example, if we have 268.3 times 1 over 10 to the power 2. Here, because we are multiplying by a fraction of power over 10, we should move the point to the left as the exponent, which is 2. So here we should move it 2 digits to the left. So the answer will be 2.683. These are very important rules of powers. One of the most important lessons that we have studied together in grade 6 is the order of operations. The order of operation is applied in a numerical expression. For example, we have studied numerical expressions in which all the operations are plus. When we have all plus, so we start from left. When we have all minus, we start from left. We have plus and minus, we start them from left. Also, if we have all times, we start from left. All divided by, we start from left. We have times and divided by. In these rules, we start from left, because these are operations of the same power. So we start from left because they are, or they have, same power. In a numerical expression, if we have plus and times, or we have a plus and divided by, if we have minus and times, if we have minus and divided by, in these numerical expressions, we start with the strongest. Start with strongest. Who's the strongest? The strongest is times and divided by from left, then plus and minus from left. Now, in a numerical expression, if we have parentheses, parentheses is the strongest. So we start first with the parentheses. In a numerical expression, if we have exponent, the order of operation will be parentheses is the strongest, it's number 1. Then we have exponent, which is number 2. After exponent, we should multiply or divide, from left. This is number 3. After we multiply or divide from left, we add or subtract also from left. In this way, we will be applying the correct rules of order of operations. My dear students, I really thank you so much, and I wish you all the best in your semester 1 exams. Please watch this video before you start solving your mathematics exam review worksheet in math. Okay, so have fun and concentrate. Thank you again.